Good morning, boys and girls. This is Mr. Giomini. Just wanted to give a shout out to Nora. She requested a little shout out, so don't want to disappoint. This is just a quick little review of some different problems that you may see on your Unit 6 Summative Assessment, which will be next Tuesday, that'll be March 6th, I believe, we have on the calendar. So, taking a look at the first one here that I have for us to look at. Evaluate for 6x plus 7y, and then I want to substitute in wherever I see an x, I'm going to substitute in 5. Wherever I see the y, I'm going to substitute in the 3. So no longer is it 6x, it's now 6 times 5, plus no longer is it 7y, I'm going to substitute in the 3 for the y, it is now 7 times 3. I now go 6 times 5, which is 30, plus 7 times 3 is 21. I now know that 30 plus 21 gives me 51. There's my final answer, 51. Let's take a look at the next one. I have r times 5 minus s. It looks like I could use some distributive property here. Let's first substitute in for my values. I now see that r is going to be equal to 4 and s is going to be equal to 8. So I'm going to substitute in. So I see the 4 or the r here, so I substitute in a 4 for it. I'll put the parentheses back in place. 5 minus 8 in the parentheses. I can use distributive property if I would like. I can also just subtract in here. I have 4 parentheses. Now, this says 5 minus 8. I'm going to kind of transfer this. Remember when we're subtracting integers, I add the opposite of the second number. The opposite of this 8 is a negative 8. I owe you $8. I paid you 5. I still owe you 3. So that is a negative. I have a negative times a positive. When bad things happen to good people, that's a bad thing. 4 times 3 we know is 12, but because we have a positive times a negative, we have negative 12 is my final product. Take a look at the next one. Some translations of word phrases and writing them into algebraic expressions. This was something that hurt us a lot, dinged us up, not only back in Unit 3, but also on this pre-test. So I have 7 fewer than. Okay, when I see fewer than, I automatically know this is coming second or possibly even last in my expression, because I am starting with something and I'm going to take 7 away from it. So it's going to be 7 fewer than the product. Product tells me to multiply of h and 7. So these two things are being multiplied together. And I'm just going to put those in parentheses. I'm going to actually keep them in parentheses. So when I go to translate this, I first have to find the product of h and 7, whatever that is. And because we have a variable and a number, which no longer is considered a number, it's now the coefficient. Remember, the coefficient goes in front of the variable. So I have 7 times something, and whatever that product is, I am taking 7 fewer than that. So I'm getting 7 fewer than that, sorry. So I'm going to take 7 away from that product. So this reads 7 times h minus 7, or I could say, hey, 7 fewer than the product of 7 and h. If I take a look at my next example here, half of the difference of 14 and 7. Half. Half means to divide by. If I cut something in half, I'm going to have 2 equal parts. I have to divide something by 2. Now, I can't find half of something until I know what I have to find half of. So that means this half of something is going to come second. And it's going to be the difference of, which means to subtract, the difference of 14 and 7. So the first thing I must do here is find what is that difference of 14 and 7 that I'm getting half of. So in parentheses I will put 14 minus 7 divided by 2. This can also be written like this. 14 minus 7 divided by 2. Alright, remember, I can't find what I'm getting half of until I find what I first have the difference here. So I'm getting half of whatever the difference was here. So I have to find what the difference is here first before I figure out what half of it is. Okay? Let's take a look at the next example here. Simplify. Okay, we're going to combine like terms. I see no equal sign. I see nothing on the other side here, so this is just an expression. I'm going to combine like terms. I like to kind of box and circle and underline. I have 7 t's. I have another t here. I have another t here. I'm going to combine all these. So off to the side, 7t plus t plus 4t. Let me make this a little bit bigger. 7 t's. Remember when we have the variable by itself, it's understood there's 1 in front of it. 7 plus 1 is 8. 8 plus 4 is 12. I have 12 t's. So I'm done with that. I have the whole number 6. There's nothing else to combine with it, so it's just plus 6. Or you know what, better do that. I'm going to get rid of this variable first. I'm going to subtract that h first, get all my variables in front. Everything with a variable coefficient will come first, and then we'll deal with that whole number plus 6. Alright, again, it's always good strategy. I made a little mistake there. I'm thinking about what I'm doing as I'm doing it. I don't blaze through it. I think about what I'm doing. Okay, next one we have 5 times m plus n in parentheses minus 2n plus 7. Okay, inside the parentheses, there's nothing to combine. I can't combine m and n's. They are two different variables. They don't want to go together. So I need to use the distributive property and multiply that 5 by everything inside of the parentheses and pay attention to the plus sign. So it becomes 5 times m plus 5 times n minus whatever's left in the outside parentheses, 2n plus 7. Pen went a little crazy there. So let's take a look. I have 5 m's here. There is nothing else that has an m, so that 5m is by itself. I don't have to combine it with anything. I have 5 n's minus 2 n's. Well, if I had 5 n's, 2 left, I'm only going to have 3 n's. And then I have the plus 7, so I'll throw that at the end. So combining like terms and simplifying this, I'm left with 5m plus 3n plus 7. Finally, graphing inequalities, solving first and then graphing them. So taking a look at this one, I have 7 times something, or 7z, is greater than or equal to 49. Now, I want to solve for 1z. I don't want to figure out what 7z's are equal to. So remember, this is multiplication here. To get rid of multiplication, I do the inverse of it, which is to divide. So I divide both sides by 7. That cancels that 7 out. I am left with z is greater than or equal to 7, because 49 divided by 7 is 7. Now, I am not putting on my number line 49. I am graphing what the z is greater than or equal to, which is 7. So I put my line here. I put my 7. I could put one more digit that is greater than 7, which is 8. One more digit which is less than 7, which is 6. I now want to graph this. Let me get a little thicker arrow here. I'm thinking to myself, okay, this says 7 is greater than or equal to. That means 7 is included in the solution set. And there's an infinite number of answers that also make this true. Anything that is equal to or greater than 7 will work. So that means 7 does work. So let me put my arrow here. I'm going greater than, equal to, or greater than 7, so that means it's going to the right. Now the question becomes, is that circle opened or closed? Is that 7 included in the solution set? Z is greater than or equal to. So yes, it is included. So circle filled in. So it looks like that. Remember, boys and girls, you get 1 point for solving it. You get 1 point for graphing it correctly, for a grand total of 2 points for that. That's a big problem. Look at my next one. I have solve for 4t plus 5 is greater than or equal to 29. Okay, I want to first get rid of the 5 because I want to solve for the t, but if I bring the t over here, I can't subtract 4 t's from 29. I can't combine those terms, so I'm going to get rid of that 5 first, get rid of those whole numbers first. So I subtract 5 from both sides. Remember, whatever I do to one side, I must do to the other. These cancel each other out. I'm left with 4 t's is greater than or equal to, let's see here, 29. 9 minus 5, I think that gives me 24. I now want to evaluate for 1t, not 4 t's. So I am going to divide both sides by 4, because I want to do the inverse of multiplying by 4, which is to divide by 4. So I'm left with, right over here, t is the only thing left on this side of the inequality sign. T is greater than or equal to 24 divided by 4 is 6. Remember, this is what I'm going to graph, not this. The final, once I evaluated and solved for t, this is what I am graphing. So I will come over here. It says t is greater than or equal to 6. I will put a 6 here. I will put one number larger than 6, which is 7. One number smaller than 6, which is 5. I now determine, am I going to the right or to the left? I am going to, let's see, t is greater than or equal to. So greater than or equal to 6. Numbers that are greater than 6 or equal to 6 must go to the right. Now I must determine, is this an open circle or closed circle? Greater than or equal to. Well, that means 6 is part of the solution set, so it's going to be a closed circle. Hope this helps prepare you for the test on Tuesday, boys and girls. Take care. Bye.